Okay, so hi folks. So this will be, I think, our first Cohere for AI webinar. It will be about the future of MLOps, open challenges and opportunities. With us, we have Andrey, who's the creator of this stack and was previously at JetBrains, which is an amazing software tools company. We've got with us also Charles Frye, who worked for Weight and Biases, which I guess is one of the foremost companies in the MLOps space, and is now at Full Stack Deep Learning, which is an amazing course for anyone interested in deep learning beyond the, I would say the basics, but beyond the part where you like do research that throw away your models and stuff like that. And we've got Shreya, who's a PhD student at Berkeley, and who has just published a really great paper on MLOps called Operationalizing Machine Learning, an interview study. So thanks everyone for coming. We will start with some pre-planned questions, but if you have any of your own questions, please send them on the Q&A, and we'll be sure to go through as many as possible. So yeah, hi folks. I'm going to start with a very general and broad question for the people who have joined but are not sure like what's MLOps. So yeah, the first question will be, what is MLOps? Let's go alphabetically. So Andrew first.
Right. Yeah. Hi everyone. And yeah, first of all, thanks for having us, and great opportunity to talk about MLOps. People have to do MLOps, and sometimes people don't have time to really reflect on what MLOps is. So it's really cool to actually have a conversation about that. So, right. A lot of people talking about MLOps, and sometimes I think especially beginners get confused about what MLOps is and how to get started. And also thanks for this important question. So if you ask me, I would probably give an answer that would probably resonate with what you can read on the internet here and there. Luckily there is a lot of resources. MLOps has a number of practices, of best practices for making machine learning easier to reproduce and easier to take into production. That's, having said that, it's a very, let's say, so it's very generic answer perhaps, but in the end, I think indeed it is all about all of that practices that you can do in order to make it easier to get your model into production. And of course, that's a lot about tools that help you follow that practices. But I think we'll have a chance to talk about that. So that would be my first answer.
So Charles.
Great. Yeah. Thanks, Andrey, for taking the first crack at that question. I did not expect to be answering questions this difficult this early in the morning for me. So I think it's a term that was formed by analogy with DevOps. So I think it's probably smart to give a definition by analogy with DevOps. So in my view, DevOps is what allows developers to actually own stuff that's happening in production. There's like a bad old world in the scarcely remembered past in which people would like package up software and they would go to an IT team to end up deployed, to end up in users' hands. And thanks to the work that's been done on tooling and infrastructure, that's no longer the world that most software lives in. But a lot of ML does still live in that world where there's an ML research team or a data science team that makes something and then they hand it off to an engineering team, they throw it over a wall and start working on something else. And so I view ML ops as trying to allow ML researchers or data scientists or whoever is doing model development in an organization to actually own the full model in production and everything around it.
And Shreya?
I guess it's my turn to give the definition. I think it's very similar to Charles, at least my thoughts. I think it's any practices that allow ML pipelines to be sustained over long periods of time, be it technical, tooling, operational, organizational. That's why I think it's so broad. You have such a long tail of applications, a long tail of stages in the life cycle. Yeah, how do we do it? Super open question.
Thanks, everyone. And I guess the next question is, when should one use or at least start caring about MLOps? Like what size of team, of project, early in the research, or more if, or like only if you care about, productionizing it. And for this one, we'll do reverse alphabetical. So we start with Shreya.
So for a while, I thought this had to do with organizational team size. Then we did our interview study paper, and it doesn't have to do with this because we'll have small companies that have like pretty robust practices that allow data scientists to collaborate with each other, to harden artifacts, deploy them, etc. So I really just think it's whenever you, as a company, have a service that you want people to use for long periods of time, or it's not just like a small pilot or a proof of concept or a dashboard that you show one time to someone, then like MLOps is absolutely necessary. But in practice, right, that if you have such like a hard boundary between no MLOps and MLOps, right, you're going to find it super challenging to get something productionized or even get any system in production. So I don't know the right answer to like when do we start incorporating hardened engineering practices into our day-to-day workflow as we train models, but I do think it's like absolutely necessary to have any like production service.
Yeah, I think I'd substantially agree with that. That maybe historically it's been on the basis of like team size and organizational maturity. But that's, I think, like an accident of history. I think when it comes to being able to allow the person who is building models to be able to create something that users can interact with or stakeholders can interact with and give feedback, and then incorporate that into the like iteration cycle for models, I think that's something that needs to be done like as soon as possible. The more tooling we can get to make that process as like easy as it can be, the way that libraries like Hugging Face and PyTorch Lightning have made training easier and easier, like I think the better. When it comes to what I think Shreya called hardened engineering practices, those kinds of things maybe can wait for when you have like larger numbers of models or coordination across like larger groups. Those, you don't necessarily need a perfectly instrumented pipeline with DVC models that correspond precisely to containers in your AWS container registry and all that.
Yeah, right. So while I was listening to Charles and Shreya, I was thinking also about, like, for example, if we compare with traditional development, software development, for example, there are also maybe similar concepts, like, for example, again, maybe not exactly similar, but still agile development, right? And when I long time ago, when I got introduced to that concept, I was fascinated by that, and of course I was, there was a lot of confusion. Okay, so what is that? When I should use it? How I should exactly use that, right? And because everybody agreed about that it should be agile, but well, there were different ideologies, like how exactly to have it, right? And nobody could agree. I mean, some people could agree to a certain extent, but there was no a single right answer to that question. That is why often, typically, when you're talking about methodology, you're not talking about very exact way of doing things, but rather of relying on a set of different practices, which you decide yourself when to use one practice and not use some other. So for example, if we take that analogy with software development, for example, there we might have refactorings or using Git or using tests. And then you can, for example, ask yourself, okay, so when should I have tests? And then, of course, you should, well, typically there's common sense and some rationality behind that when it makes sense to have tests. So there's some empirical data to back it up, but mostly it's common sense. And common sense says that you need to have tests. That's what you have to agree with. And if you plan yourself to be a software developer in the future, you better learn how to write tests. And there is no other way here. We can say same about versioning data, right? Sorry, let's jump into MLOps. Versioning code. So basically, what I'm just trying to say is, we have to understand these practices, where they come from, and then follow common sense about this particular situation. But in the, let's say, as a general rule, it means that all of these practices are important, and at a certain point they have to be taken care of. And that's why, for example, if we are talking about raising the quality of software, for example, right, where we use this methodology as a tool to raise that level of quality, which means we have to adopt these tools and these practices. So which means that we have to adopt MLOps practices if we want to increase the level of quality in machine learning. Yeah, that would be my answer.
Okay, thanks everyone. So I guess for my next question will be, how can MLOps tools be used to improve publishing and in some sense the, let's say, scientificity, like the science likeness of machine learning in general? And we go back to alphabetical.
Sorry, can we have this question maybe repeated to make sure?
Oh yeah, so how could MLOps help more on the, let's say, science side, more help with publishing, with guaranteeing reproducibility, and helping make machine learning in some sense a more scientific field?
Yeah, right. So alphabetical order means me. I'm starting, right? Good. Again, probably I'm not the best to answer that question. If, for example, what we mean with the question is like academia, like from the academia research point of view, if we can leverage MLOps to increase the quality of the research and reproducibility of it. So it's hard for me to answer that, because, well, I come mostly from their kind of production side of things. But if you press me on that, I would say that MLOps has rather nothing to do with research. I mean, in general, it's helpful, but I can be totally wrong here, but to me, it seems that when we're talking about the operations, we're talking about the production. So basically, we're talking about something that needs to be taken into production. So basically, something as a part of the production cycle. But I would love to hear other opinions on that.
Yeah, I think mostly I would agree. There are forms of like reproducibility of research that are less about the standards in like software ops and more about just the standards in other research fields around reporting of what you have done in such a way that other people can reproduce it. That machine learning, because of its embrace of conferences and archive and Twitter as the way that research gets shared, has kind of dropped a lot of those standards to dropping those standards maybe pretty much exclusively to the field's detriment. The rapid pace of iteration has its own other benefits. But I think maybe the more direct place where I see an interaction between MLOps and research is that MLOps is changing the way that people think about and build machine learning powered technology, orienting more towards an iterative style, orienting more towards maybe some form of continual learning. And that should adjust the research agendas of people who are building models. Perhaps if you want to be the 20s, one of the people who spearheaded the design of ImageNet, they should maybe be building something that looks a lot more like a stream than a database for people to learn off of. So that's where I would see maybe more a more fruitful place for MLOps and academia to come together, rather than NeurIPS mandating that everybody incorporate weights and biases into their papers.
I feel like I have a lot of thoughts on academia and MLOps. The short answer is that there's a reason that I'm in like the databases field. I think that like the NeurIPS, ICML, et al. Like main tracks aren't quite. I don't even know if it is their prerogative or the most important thing for them to be thinking about these kinds of issues. But management fields, right, like from I don't know 1960s from the Cod paper, have been thinking about how do we make it easy. How do we extract away all the internals of like storage, execution? How do we provide query engines such that users can interact with their data? And I totally think MLOps fits very squarely into this paradigm. For that, yeah. So for that reason, I really think that there is a home in academia to do research on not just MLOps best practices, but what kinds of data management systems can be built to help people with these challenges. And there's a lot of the VLDB SigMod papers in the last 2 to 3 years on these kinds of tools and systems. There's new tracks like the scalable data science track in VLDB, geared specifically for these kinds of systems for large scale data science, or I don't even know, a scale of data science. I don't know if this answered your question though. I feel like it's probably a separate.
MLOps for research and research for MLOps. And I think, yeah, research for MLOps seems very good. MLOps for research, maybe. Yeah.
Oh, I see. MLOps for research. I have a lot of mixed feelings on this. I have a project that I am working on. I haven't touched it in 6 months. But specifically, what Charles was saying about like the streaming version of ImageNet. I came in grad school like, oh yeah, we should definitely work on these things to incentivize ML researchers to work on the quote unquote right problems. But I think that's a little bit misguided. Like, who's to say what are the best problems are to work on? Like, the whole point of research is inherently exploratory. People should do what their like personal tastes are. And they're so, I can't even reason about like, there's one correct way to do like continual machine learning. Like, I can totally see a world in which we do batch retraining and batch prediction and just serve like materialized predictions, and we just do this every hour compared to like on-demand execution or on-demand retraining, right? Like there's no right answer that I have to these questions, and I think that's what makes it hard to prescribe like here is a paradigm that you ML researchers should adhere to, here's a benchmark you should do. But there are some people providing all sorts of benchmarks, like the clear benchmark. I think NeurIPS 2021 is a good example of this. I think there's also like different paradigms of how these are evaluated. Like Bench is a good example of like different like evaluation agendas. And then of course, I think like a few people in my lab or broader UC Berkeley Yeeks labs are working on just notion of like evaluation. My friend Deborah, she does a lot of work in this area. So I think like it's definitely covered. Whether it makes sense for like MLOps to focus solely on this, I don't think so. Again, it's like it's academia's personal taste. Like research is all this personal taste, right? So sorry, I don't have an amazing answer to that either.
Okay, thank you for your answers. So let's go now to the question of tooling. We'll begin by like what we have, and so if everyone could mention 2 or 3 MLOps tools they believe are very interesting, important, and why, that would be very interesting. So we'll begin with Shreya.
Tools are the current tools or open problems that tools are trying to solve.
I would begin with current tools, and then the next question will be about open problems.
Great. Okay, so I think the things that have been catching popularity recently, experiment tracking tools the last 2 years or so, like they really 10x the velocity for any model developer. You don't have to go and copy your results to a Google spreadsheet right now. You can just simply instrument your like training script and then see kind of what model to choose in an inherently experimental area. Another one that I think is very interesting is these like end-to-end kind of machine learning or MLOps kind of frameworks. TFX is a good example of this. Just the concept of having this end-to-end allows you to get forms of provenance, forms of logging that a very customized stack would not be able to easily get. Especially like if you allow your data scientists to use whatever tool they want, whatever programming language or model development framework reality is, right? Like your infrastructure team needs to support kind of the ability to get provenance for any single prediction through that highly customized stack. So that's hard. I think end-to-end tools are just kind of mitigating this problem. Whether or not they actually help people with MLOps, they do help people with some like necessary logging stuff. So those are 2 tools.
Yeah, I definitely agree that experiment management is something that has been like solved well, and there's been a ton of tooling progress in the last couple of years. And I'm not just saying that because I worked at Weights and Biases. I think that there's been a lot of work with other tools, with MLflow, with Comet, with Neptune for really like as Shreya said, 10xing velocity. I had a really disgusting system of interlinked Jupyter notebooks and a Google Doc, not even a spreadsheet, just type in what I did that day, what happened, take some screenshots. It was rough. It was not good. So that's I think one of the biggest wins, and that sort of has proceeded. We've been kind of proceeding out from training, like the tools for writing neural networks got good 5-6 years ago with PyTorch and TensorFlow 2. The tools for what kind of engineering on top of that with Keras, Lightning, Hugging Face, that kind of layer solidified in the last couple of years. Experiment management solidified in the last couple of years. So we're kind of like in the like diagram everybody draws of the machine learning pipeline. We're kind of moving down the pipeline. The place where I'd like to where I'm starting to see like some other good tooling is at the other end, starting from like actual like production and deployment of models. I think, for example, the thing I'm kind of most excited about recent developments in is like serverless setups for GPU accelerated workloads. It just fits so neatly with the way you would like your machine learning models to run. They're functions that you want to run in the cloud, so we should be using cloud functions, it seems like to me. But we've been held back by the lack of tooling, like all the way down to the level of effectively like hardware and the layers just above hardware around like virtualization of GPUs. And starting to see that tooling percolate up from stuff built by NVIDIA up to stuff built by fast moving startups on top of that. Maybe Triton kind of being the interface layer there, the Triton inference server. I think the opportunity to substantially cut costs and make the early phases easier with better sort of inference tooling is the other side that I've seen some good progress on.
Right. Yeah, for me, it's quite difficult to answer this question. Because again, when we it's really hard to tell which tool is more important or most valuable. For example, if you go to the field and then look at how people actually do that job, you'll realize that most of them are not using these fancy tools at all. And people often use things that sometimes they think they should never use, but they have no alternative and then they have to use them. So for example, SSH, right? It's quite, I have mixed feeling about that technology, right? What it allows you to do is, for example, go to a remote machine and then basically use that resource of that remote machine to run what you have to, what you want it to run. And for example, this is often used with basically the development experimentation when you run different kind of scripts, ad hoc training and all. And it's not designed for ML or ML ops for that matter at all. Or sometimes people use Snooks or Screen as something to keep the session up, you know. And if you come to think this is horrible to use these tools, but people do use them, and there's not so many ways of basically not using them. And basically that's what they use most of the day. They basically just work with SSH directly, they run Python scripts, they watch this, well, I mean, progress is just very slow. And I often talking to some people and then like I'm saying, why are you using QDM to save your experimental metrics? Like, why I'm not using, for example, weighted biases? And like, huh? What it? And I mean, it sounds ridiculous, but in fact, most of the folks in the field actually use very old school, very, yeah, I would rather call them old school technologies. So basically, this is something that fascinates me. That sometimes people ask, okay, so what's next in the machine learning? I think it is just getting started, and then it's basically we are about to see the, well, what is it? Basically, the raise of their developer tools in machine learning. So basically, what we see now, I would rather say, again, this is very personal, very subjective speculation, but I would rather say that we are ahead of, sorry, not ahead, but we may expect to see a lot of tools to other to how people do machine learning. So basically, and basically, what I'm just trying to say that there's always two worlds, for example, at least two worlds. There, a world how people do that most of the time, how the majority of people do that. So that's very old school way of doing things. And there's always this modern, you know, kind of cutting edge way of doing things. Basically, people try very strange things. Some of them actually end up becoming the mainstream tools. But so I'm very much interested to see which tools will go to the mainstream. So, and for sure, weighted biases and things like experiment tracking is certainly one of them that already now started to go mainstream. Then, of course, right now, it's people are confused about deploying the model. So, what is the easiest way of deploying my model? And to be honest, this is ridiculously. There is a ridiculous lack of answers to that question right now. So basically, yeah, there are lots of solutions, but there's no proven ways of doing that now. And I'm very much looking forward to see more standards, more tools and services too, of course, to help people get the model deployed.
Hey, thank you very much. I'll go for the next, let's say, prepared question before then going to the audience questions. And Andrew has already touched on it, but it's more about like what tools do you think are missing and do you think will appear for helping with MLOps? So what do you think, going from the title of the panel, like what's the future in that sense of MLOps?
The future of MLOps. Flattered to be asked about that. So for me, it's always easier to talk about something that I can relate personally. So, for example, if you ask me how I personally would like to see the future of MLOps, then I would say that of course I'd like to see more let's say common developer tools to appear. So I'll explain what I mean. So right now there is quite a few, let's say what word we can use, the MLOps platforms, for example. So basically they offer you end-to-end quite opinionated in a framework how to do things, and basically you just have to follow that way, and if you, for example, change the vendor, well, it gets slightly different, and then you have to basically rewrite everything or re-implement or relearn. It's similar, but it's still different. So basically, it's just another opinionated solution. So, for example, I'd love to see more tools like Git, for example, or like Terraform, which brings, which kind of become the kind of the standards for everyone to follow. Yes, you can deploy models with different vendor, you can use different kind of compute, and you can use different kind of storages, frameworks, libraries, but still, I'd like to see more standardized tooling. That's one thing. Secondly, I'd love that tooling to be integrated into the developer environments. Again, someone coming from this, from JetBrains, from developer tooling background, yeah, sometimes it really hurts to see people being pushed out for a certain reason from the IDs to some web interfaces where they lack a lot of productivity boosters that typically developer environment offers them. So, for example, I mean, we can just we can at least try to agree that the code editors is kind of the default way of writing code. So, and there's certain, let's say, level of expectations, what you expect from your code editor. Your code editor should allow you like have this code completion, refactorings, code navigation, and all, and then it should have some integration with Git. Ideally, it should be the ID which you use normally. It shouldn't be some other ID which you have to jump into, and then your productivity just ruins. It's just ruined. So basically, developer environment, developer productivity is super important, and I'd love to see more tools being integrated into that, not trying to reinvent that. Yeah, thanks.
Yeah, so I'll be brief on this one because I want to make sure we get to the questions folks have asked in the Q&A. I think maybe I could have already answered what I wanted the future to include by talking about better deployment tools around like serverless GPU inference. There's a lot of difficult problems to resolve with containerization for accelerated workloads that for folks like Banana and replicate with their cog tool. They're working on this. There's substantial improvements, but there's like a pretty big last mile problem of resolving how to make sure that you can build on a Mac with an M1 and deploy to your NVIDIA GPUs in the cloud. That's kind of unsolved problem, and sort of abstracting that away so that people have to think as little as possible about the hardware unless they really need to squeeze all the juice out of it. That's something I'd really like to see.
I highly encourage people to read the paper we just put out from Systems Foundations group at Berkeley for like lists of, not lists, but 2 or 3 like big open problems. Talk about one of them being kind of highly precise data validation in continual ML pipelines. Suppose you have like a model that's retraining every 5 hours, and you do some sort of continual validation when you retrain. But what happens when your entire snapshot is broken? So your validation step passes, but you've promoted a terrible model into production. How do you catch that? How do you do validation with respect to historical partitions? How do you do this precisely? Make sure like you're not sending too many alerts and people fatigue. I think these questions are open and ripe for tooling.
Okay, thanks a lot. So let's for the audience questions. So the first one will be, what will determine the success of MLOps startups in the next upcoming years? If best practices are open source, what can possibly be the competitive advantage? Is there a competitive advantage? Okay.
Like there's a lot of belief that like software is the moat, or the like tool is the moat, and I think that's something that I believed when I was still doing research before jumping in to work in industry. But what I found is that nobody wants to actually run a database, or rather people want to run as few databases as they can. And so what that kind of looks like is for model registries, for experiment tracking, for monitoring, and like ingressing all of the things that are happening in your models. All of those problems are resolvable with databases, but nobody wants to be on the hook for all 3 of those on top of everything else, for much the same reasons we don't run our own Git servers. And the competitive advantage, I think, the way I would like to see things work is these technologies are open, and anybody who wishes to run their own database to solve a particular MLOps problem is free to do so. But most organizations will choose to run to get a managed version or a white glove version or something like that.
Andrey or Shreya, if you want to try to handle this question.
To add really, Charles.
Yeah, I mean, if you ask me, I would agree with Charles. It's a kind of a general question, which makes it hard to answer. And the worst answer is it depends. But certainly the tool should create the value in the end. So basically, we can measure it different ways, but in the end, it should create value for people. People should find this very unique. That's one way. Or there should be so great demand, and it's so hard for people to get this value from others in that quantity. So in that case, typically, adoption basically follows that great need. And for example, we can see that right now in the MLOps, not MLOps, but machine learning space, for example. There's a great demand for transformers, right? Because they work so great, and people are looking for ways to use them somehow, and also experiment tracking people. It is just so basic need, and people need that in so great amount, so high amount, that even though there are different vendors right now, people still, the adoption comes. Yeah, that's my comment.
Okay, thanks for the answers. And now a question about adoption. So, the question is, I've been using old school tech for our ML projects and trying to adopt newer and more MLOps focused ones. Which common pitfalls have you seen that we should know about when setting up our first version? So basically, what are like the common pitfalls when adopting MLOps tech and practices? And we can begin with Andrey.
Yeah, maybe I could just quickly comment on that. And probably it will be applicable not just to machine learning, but in general. There are several things to keep in mind. Like, for example, one is like, what is the purpose, right? One purpose could be learning different frameworks, different new concepts, new practices, and that's a great reason, and that's where you can explore things, and you could invest in exploring things, and let's say you are driven by that objection, this goal. So you should optimize your process for learning. Basically means that you should aim for trying several things, not just invest into one only. If, for example, if the purpose is different, and for example, your purpose is to set up the process up to speed, and then get your project started, then of course you should optimize for that, and probably you should find some compromise between trying most complicated tool and most and then also time that you can invest. And maybe to add on top of that, sometimes people underestimate how much time it might need to support certain technology. So for example, certain technologies have to require you to rewrite your code, for example, or to implement your solution. So, and it's the biggest pitfall when you invest into that tool, and then you basically have a lock-in into that technology, and then you basically think twice whether you have to basically drop that technology if you don't even like that, but you cannot do that easily. That will be a problem which is to keep in mind.
Yeah, I think one of the most common issues I see when people are adding more tooling to their projects is kind of like a pendulum swing hard from no tooling to too much tooling. They're like, okay, I gotta have a feature store, obviously, and I gotta have my model registry, and those have got to talk to each other. And like all of a sudden, it's 3 months later, and you've implemented a lot of tooling and no machine learning. So I would say, like, it's kind of inevitable, and I think I had a similar journey with testing, where once I discovered testing, I was like, this is the greatest thing since sliced bread. Test everything, 100% code coverage, and took me a while to realize that there's a happy medium. So there's kind of like a natural evolution there. You can try and get out ahead of it a little bit in your organization when you're setting up your first projects by trying to add tooling gradually, or or always set aggressive deadlines on actually serving, on actually getting stuff out there. But to a certain extent, you just gotta experience what it feels like to be weighed down by your belt of tools, and slowed down by it rather than accelerated by it.
I don't have much more to add. I think we should move to the next question.
Okay, so I guess for our final question, There are so many tools coming out from many vendors. For companies adopting them, they end up getting too fatigued, maintaining different vendors, and resolve towards using something already supported by cloud providers. What do you consider will happen in the MLOps ecosystem in the future? So do you think there will be more integration, centralization, and we begin with Shreya, if she has something.
Yeah, I don't think this problem is specific. Maybe it's specific to MLOps right now, but like throughout the history of data management, we've had tool bloat through multiple hype cycles. And what happens is that the companies that find product market fit stick around, and the companies that don't stick around. So I think it will be the same thing for MLOps. Why would it be otherwise? Is my question. I think the one thing that I accidentally muted myself. The one thing that's new here is a big shift to cloud. I think that's happened in the last few years. The implications for tooling on top of the cloud might be different. Not just competing with cloud vendors, but how do you build tools that work in a cloud native environment? That's like an open question, but it's still like, I guess, what do you consider will happen in the MLOps ecosystem? I think that those who find product market fit will stick around.
Yeah, I'd agree. I feel like there's sort of like periods of explosion, gold rushes, and then busts. The state of California, where a lot of these vendors are located, is known for a history of booming and busting. So that doesn't necessarily mean it's going to be like an AI winter or an MLOps winter, but it just means that there will be, consolidation, acquisition, acqui-hiring, things like that as people sort of solidify around the preferred tools. Hopefully that means good integrations with the major cloud providers. Hopefully that means like cloud agnostic tooling for these things so that you don't have to worry about whether you're doing your experiment management on AWS or GCP or whatever. And maybe more consolidation into end-to-end tooling. So like as these tools consolidate, they become more like SageMaker. So perhaps that's the end state, is for Hugging Face, PyTorch Lightning, Weights and Biases, and Banana to all resemble SageMaker in the end.
So I agree with what's been said here. I would add, it certainly sometimes may seem as there is too much, talks about new tools. There is too many new tools. I think that's a very natural process. This is a very healthy sign about the ecosystem, telling that something going on, something being trying to folks trying to solve certain problems that exist, and no doubts about these problems in the field. So this is a very healthy sign to me, saying that we can expect a lot of, let's say, a new wave of tooling. So for example, if we compare that with DevOps, right? So there's been so many jabs at this problem, right? There've been so many in-house solutions. There have been Puppet, there have been Chef, there have been Ansible, then there have been Vagrant, and and Terraform, and still there are new tools appearing there, and then we're integrating with existing tools. So nothing can stop the progress, that's for sure, and we shouldn't be afraid of that. I mean, simply because there is no other way. Sounds a little bit kind of vague, but that's what I think about it.
Okay, so thank you very much, everyone. Your answers have been amazing. And thanks for accepting the invitation. And I guess that's it for today.